Obviously, all of the movies in this little series then are about delta H, and I'm going to try splitting them up into little movies rather than sort of have a couple of big ones for you. Now, this first movie is all about the fact that delta H is a molar quantity. Now, what exactly do I mean by that? Well, consider this decomposition reaction here. Calcium carbonate goes to calcium oxide plus carbon dioxide. And I'm going to tell you delta H for this is plus 180 kilojoules. What information can we get out of that? Well, first of all, of course, it's positive. So that means that this reaction needs heat in order for it to occur. Secondly, as I said, delta H is a molar stoichiometric quantity. What that means is that when 1 mole of calcium carbonate reacts, because in this equation it's 1 mole, well then it will need 180 kilojoules. 1 mole of calcium carbonate, delta H plus 180 kilojoules. The plus means it needs it. Similarly, every time that we make a mole of calcium oxide, we will need 180 kilojoules. And every time we need 1 mole of carbon dioxide to be produced, it needs 180 kilojoules. Now, this doesn't mean there's 3 times 180 kilojoules for this whole reaction to happen, but what I mean is that we express the delta H in terms of the moles. 1 mole of calcium oxide, that is associated with 180 kilojoules. 1 mole of calcium carbonate is associated with 180 kilojoules. 1 mole of carbon dioxide is associated with 180 kilojoules. Now, if I were to react 2 moles of calcium carbonate, well, that would need 2 times 180 or 360 kilojoules. Okay, when I write this delta H, it is a molar quantity associated with how I write the equation. Should I have been silly and written the equation like this? 2 calcium carbonates goes to 2 calcium oxides plus 2 carbon dioxides. Nothing wrong with writing the equation like that. It's just by convention you usually try and reduce the coefficients to the smallest possible number. But if I had, for whatever reason, had a brain whatever and decided to write the equation like this with extra coefficients of 2 in there, well, then the delta H for this reaction that I should write is 360 kilojoules, because the equation talks about 2 moles of calcium carbonate. 2 moles of calcium carbonate needs 360 kilojoules. Now, that last equation I left as it was because it was rather a trivial one, just to get the idea across, but let's write a slightly more interesting one. 4NH3 plus 5O2 goes to 4NO plus 6H2O, and I'll tell you delta H is minus 900 kilojoules. Now, first of all, of course, the negative sign there means that this reaction gives off heat. How much heat? Well, what the equation is telling me is that when 4 moles of ammonia react, then that's going to be a minus 900 kilojoules change, or in other words, 900 kilojoules of heat's given off. On the other hand then, if only 1 mole of NH3 reacted, well then the heat change would be minus 900 over 4, or minus 225, which means only 225 kilojoules would be given off. I've got a quarter as much NH3 as the equation is telling me, so the heat change will be a quarter as much. 5 moles of O2 react. Well, according to the equation, when 5 moles of O2 react, the heat change is minus 900, or 900 kilojoules given off. On the other hand, if 1 mole of O2 reacts, well, then you're not going to get 900 kilojoules heat change. You're going to get 900 over 5, or minus 180 kilojoules for a heat change, because you've got 1/5 as much O2 as the equation is relating. And so, in other words, 180 kilojoules given off. I'm going to go through these other two, but hopefully you can pause it and say the words along with me. So 4 moles of NO, because there's 4 moles of NO produced in the equation, the heat change is minus 900. But when 1 mole of NO, well, that's a quarter as much as you got, so the heat change would be minus 900 over 4, or in other words, 225 kilojoules given off. And then, of course, with water, the equation is talking about 6 moles of water, gives us a heat change of minus 900 kilojoules. So 1 mole of water would give me a heat change of minus 900 over 6, or in other words, 150 kilojoules of heat given off. Really, really important that you appreciate that the value of delta H that is associated with an equation refers to the molar quantities within that equation. Next movie, we'll do a couple of examples associated with that.